Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the data science department in Institute of Aeronautical Engineering. In this video, I'm going to discuss about how the data is going to be presented. So what are the different ways that are available for presenting the data? So before going to see the data presentation, so let me explain what is the basics of this. So what is the data? So that is nothing but a set of values recorded on one or more observational units. So that is either it may be an object, person, any real world entity could be considered as a data here. And then there are different types of data available. So first one is qualitative data, and then quantitative data, discrete data, continuous data, and then primary data or secondary data, and then nominal data or ordinal data. So data is nothing but a set of values, so that is recorded on one or more observational units is nothing but a data. So the examples of the data will be object, and then person also considered as a data. Any real world entity should be considered as data here. And then there are different types of data available. So very first one is quantitative data, and then qualitative data, and then it may be a discrete data or it may be a continuous data, and then primary data, and then secondary data, nominal data, and ordinal data. So that these are the various different types of data that are available. So in previous slide I discussed the difference between qualitative data and quantitative data, and then discrete data and continuous data, primary, secondary, and nominal and ordinal. So let's see one by one. So what is the qualitative data? So qualitative data is also called as enumeration data. So the enumeration data will be considered as a qualitative data. And then the qualitative data represents a particular quality or attribute. So they're right. So the qualitative data is going to represent the quality, or it may be able to represent attribute. So there is no notion of magnitude and then size of characteristic here. So they, as they are going not be measured here, and then it can be only expressed in the form of numbers without unit of measurements. So example, religion, sex, blood groups, etc. Right. So the qualitative data is also known as enumeration data. So it can able to represent only the particular quality or an attribute, and there is no notion of magnitude or size of characteristic is not going to be measured here. And then it can able to express as in the form of numbers without unit of measurements. So example, religion, sex, blood group, and etc. And then when it comes to quantitative data, so the quantitative data is also being called as measurement data. So here we are going to maintain the magnitude here, and then this quantitative data can be expressed as a number without unit of measurement here. So let it be height. Suppose I want to represent height, then it should be in the form of centimeters, and then hemoglobin should be able to represent the form of g/%, and vp in the form of hg, and weight is in kg. So like this. So this and all will be considered as a quantitative data. So the quantitative data can also be called as measurement data, and then this data is going to be have magnitude here, and then this one is going to be expressed in the form as a number or with and without in the form of measurement. So example will be height in centimeters, hemoglobin in percentage, bp in hg, and weight in kgs. So these are the some of the little bit information about the data as while we consider qualitative and then quantitative. So the qualitative is going to be considered based on the quality and then attribute, whereas this quantitative is going to be considered mainly on the measurement of the data here. Then comes to discrete and continuous data here. So the discrete data is nothing but here we always get a whole number here. So example, number of beds in hospital, and then malaria cases, like that. So we can able to count. There should be a whole number here. So the discrete data should be all the time how to represent as the form of whole number only. That means the number of beds in hospital count. So the count is going to be represented should be discrete data. Whereas it comes to continuous data, it cannot take any value that is possible to measure or able to possibility of getting the fractions also here. So example HB, level, height and weight. So then we can able to get some fractions also. It may be, suppose the weight should be somewhere 108.2 kgs and height is 99.4 centimeters, like that I can able to measure it. So you can also get some fractions, right? That should be considered as a continuous data. So the discrete data is nothing but a whole number, and then the continuous data is nothing but a measure, or it may be able to represent the form of fractions. So let me express some of the differences between this qualitative data and the quantitative data. So the quantitative data HB level should be in GM percents, whereas anemic it should be non-anemic in nature, and then height in centimeters can be used, and then here I can able to represent it as a tall and short. And suppose I want to represent the BP in mm of Hg, here I can able to represent the form of quality as hypo, normo and hypertensive. Like this I can able to represent it here. And then suppose I want to represent IQ scores, so that might be able to represent the form of qualitative data as a idiot, genius and then normal. So these are some of the differences, right? So when it comes to quantitative data and then qualitative data. So the quantitative data means where can able to represent the form person. That thing should be represent what is another way. How can able to represent it in the qualitative data? That should be anemic or non-anemic in nature. And then similarly, quantitative can able to represent the form of centimeters. The same thing I can able to represent the form of tall and short, well kinds, right? While I can able to represent it in a qualitative data. And similarly the BP, so the BP in mm of Hg, so same thing, how can able to represent it? That should be based on the values. I can able to tell that should be a hypo data or normo data or hypertensive data. And the IQQ scores, so that may be idiot, genius and then normal. And then let me see about primary and then secondary data. So the primary data is the one which is going to be obtained directly from an individual and then gives some precise information only. Whereas when it comes to secondary data, the secondary data is going to be obtained from outside source. That is, example, the data what I'm getting from the hospital record, census, that and all will be considered as secondary data. So in the previous videos, I discussed what are the primary, secondary sources. Similarly, here the data will be also two types: primary data and secondary data. So the primary data is nothing but the where the data is going to be obtained directly from an individual, and again it can able to give some precise information. That should be the original one. And then the secondary data, so secondary data is going to be obtained from outside source. That may be example, that may be the data that is going to be obtained from hospital records and then census. So nominal and then ordinal data. So what is nominal data and ordinal data? So the nominal data is nothing but the information or the data that fits into one of the categories. So but the categories cannot be ordered one above the another. So example, the color of eyes, race, sex, like this. So that one should be treated as a nominal data. So the nominal data is nothing but it may be information or data that can able to fit into one of the categories, but these categories cannot be ordered above one another. That should be the nominal data. Suppose color of eyes, race and then sex. And then ordinal data, the ordinal data means here the categories can be ordered. So there should be one particular order should be maintained for the categories, but the spaces and class intervals between the categories may not be same here. So there should be some class intervals in between the two categories, but they not should be same. Suppose example, the ranking in the class or exam here. So that is the difference between the nominal data and then ordinal data. So the nominal data means, so it should be a data where you can able to fit into one of the categories, and ordinal data means where these categories can be ordered in between the class intervals of the categories. And then collection of data here. So the collection of data should be done very carefully and then thoroughly, and then the units of measurement should also be clearly defined, and then the records should be correct, complete and clear, sufficiently concise, and then arranged in a manner that should be easily to comprehend. So the record should be a very correct one, and then complete one, and then very clear one, and then sufficiently concise and arranged in the manner that is to be easily comprehended. So the collection of data should be in one of the feature. That means that the data what we collected should be accurate ones. And that means it measures the true value of what is under study. That should be the accurate one. So that it measures the true value of what is under study. And then valid. So valid means it measures only what is supposed to be measured. Precise means which can able to give some adequate details of the measurement. Unreliable means it should be dependable. So these are the features that the data what we collected from the various sources. That means accurate one, and then valid one, precise one, and reliable one. Accurate means we are able to measure the true value of what we are going to understudy, and then valid means it measures only what is supposed to be measured, and then precise means we should be able to give some adequate details of the measurement, and then reliable means it should be dependable. Next one, we're going to see about what are the objectives of the classification. So the data is to be classified into different ways that should be easily understood, and then this one is going to present the facts into the simpler form, and then this able to facilitate the quick comparison, and then it also helps for the statistical treatment such as average, depression, etc., and then it can also detect the error easily. So these are the objectives of the data classification. So the data what is going to be classified so is more easily understood, so that you can able to present the facts in very simpler form, and then you can also facilitate very quick comparison, and then it also helps for further statistical treatment such as average, depression, etc., and then you can able to detect the error easily. So this classification of data is nothing but the process of arranging the primary data into a definite pattern and then present it in a systematic way. So so the classification of data is nothing but the process of arranging the primary data in a definite pattern and then presenting it in a systematic way. The crude data, that is what we obtain from the experiment or survey, is going to be classified according to their properties here. So the classification can be done by qualitatively or quantitatively, right? So the classification is data is nothing but the process of arranging the primary data into definite pattern, or I can able to present it in a systematic way. And then the data what we're getting from multiple sources, that one should be treated as a crude data, or the data what we're going to obtain from the experiments or survey, so that is to be classified based on their properties. And this classification can be done either qualitatively or quantitatively. Types of classification here. So qualitative classification and then quantitative classification. So qualitative classifications again will be geographical classification, chronological classification, and then qualitative classification. Well, quantitative classification means we're able to uh, defined as a discrete classification, or can able to define as a continuous classification, right? So the data is going to be classified into two types. Just now what I said in previous slide, that should be qualitative classification and then quantitative classification. So the qualitative classification is nothing but geographical classification and chronological classification and then qualitative classification. Similarly, this quantitative classifications is divided into two categories, that may be discrete classification and then continuous classification. So what is a qualitative classification here? So this, let's see one by one. First one is geographical classification. So geographical classification is nothing but, so the data what I am going to classify based on the location of occurrence will be treated as a geographical classification here. So the geographical classification means where the data is going to be classified based on the location of the occurrence. That is, it may be an area, or it may be a region, or it may be a category points, and then district wise. So these are the some examples of this geographical classification. And then chronological classification means where the data is going to be classified by the time of occurrence of the observations and then events. So right, so the data that is going to be classified based on the time of occurrence of these observations and then events will be treated as a chronological classification. And the categories that are arranged in the chronological order. Example, number of trachoma points recorded from 2000 to 2010. That should be treated as a chronological classification. So qualitative classification will be divided into two types. Geographical classification. First one is that geographical one, and second one is the chronological one. So geographical means where the data is going to be classified based on the location of the occurrence. So that is area, region, category points, and then district wise. So chronological classification means here the data is going to be classified based on the time of occurrence of observations and events here. These categories are going to be arranged in chronological order, that is number of trachoma points recorded from 2000 to 2010. Next one is qualitative classification. So here the qualitative classification means, so here the classification is going to be done according to the attributes here. That should be qualitative classification. So here the data is going to be classified accordingly some quality such as religion, literacy, sex, and then occupation, etc. So that one should be as qualitative classification. Suppose if the data what I am having, that should be classified based on the quality such as religion, literature, etc. like that. That should be qualitative classification. Again, this qualitative classification is divided into two categories. So first one is simple classification, and then second one is manifold classification. So simple classification means here the classification is made into two classes, such as classification by male or female, right? So classification means here that should be done in two ways, two classes. So that one, the first one is classification by male and then classification by female. And then second one is that manifold classification. So manifold means two or more than two attributes are going to be studied simultaneously. That one should be considered as manifold classification. So here the classifications are classified according to the sex, and then again martial status, and then literacy, like this. So the qualitative classification means the classification is to be done based on the attributes here, and then the data is going to be classified according to some quality such as religion, literature, etc. A simple classification. So here the classification is to be done in two classes. So such as classification by male and female, that should be considered as simple classification. And the manifold classification means, suppose if the data is going to have more than two attributes, that one is going to be studied simultaneously at that time. That should be manifold classification. So here the classification is to be done according to the sex, or again martial status, and then literacy again. So next, once the data is going to be classified, so now how can able to present the data here? So there are two ways here. So very first one is tabulation, and then second one is graphical representation of the data. So the tabulation. So tabulation is the one of the method where you can able to represent the data in the table form. So right. So the data will be of different types like qualitative, quantitative, nominal, ordinal, primary, secondary, like that. So we're having different types of data, right? So that data is classified in two types, mainly qualitative and qualitative. Again, so all the time we have to focus on the qualitative data only. So in order to make this tabulation, let's see the explain what is the tabulation here. So the process of systematic organization and then recording of long series of data for further analysis, and interpretation is to be done in the form of rows and then columns, right? So the process of systematic organization and the recording of long series of data for further analysis and interpretation into two or more columns is nothing but a tabulation. And this tabulation should be concise one, logical one, and orderly arrangement of the data in the form of rows and columns, right? So what is the data I'm representing the form of table, that should be very concise, logical, and then orderly arrangement of the data, that should be in the form of rows and then columns. Let's see this table, what I showing in the slide. So let me take this frequency distribution table for the qualitative data. So here one column I'm representing the characteristics, whether it is a male or female, and then the population I'm representing as the second column, and then percentage I'm going to represent it as a third column. So these are the values I'm going to represent in the form of a table here. So characteristic means male and then female, and then population means what, how much population. So the male population is 7.7 millions, and then the female will be 6.14, and then what should be the percentage of the male, 53.52, and then 46.48 will be the percentage of the female. So like this I can able to represent the data in the form of table. Similarly, I can able to represent the height of the students. So up to 4 inch or 4.5 inches, how many number of students are present, I would like to know, so that I can able to represent it. One second column, number of students, right? Similarly, how many number of students that are present in between 4.5 to 4.8, so it will be 16, right? So I like this, I can able to represent it. And then in between the 4.8 to 5.11, so how many number of students are present, 12. And then in between 6.2 to 6.5, how many number of students, 8. So what is the total, 41. So like this I can able to represent the data in the form of tables here. And then what is the usefulness of this tabulation? So it's presents an overall view of findings in a simple way. So there is a very best useful of the tabulation, where what is the data we're gathering. So the data will be in, not in preferred view. So that what we are going to do, we have to present that one as simple as possible in the simpler view through the tabulation. And then you can able to identify the trends, what is the current trends that is following in the tabulation. And then it should also display the relationship in a comparable way between the parts of the findings. So that we can able to establish, I can able to identify the relationships in between the some part of data to the other part of the data. And it conserves space and reduces explanatory and then descriptive statements to be minimum. So next useful is that, so it conserves space, and then it can also reduces the explanatory and then descriptive statements to be minimum here. And then it also facilitates the process of comparison. So you can able to compare the data very easily by seeing the tables. And then you can also provide the basics for the various statistical computation. Suppose if I want to make some calculations like total, average, and find the biggest value of among the tables, smallest one, like that, simple classifications, computations should also be done very useful easily here by making use of this tabulation. So these are some of the advantages also I can able to told as. And then so what is the usefulness of the tabulation? So tabulation should able to present the overall view of the findings in a simpler way, and then we can able easily identify the trends, and then we can also able display the relationship between the various parts of findings, and then it should also conserve space and reduces the explanatory and descriptive statements to be minimum, and then it should also facilitates the process of comparison, and then it should also provides a basis for various statistical computations. And then next one is that graphical representation. So tabulation is one of the method where you can able to represent the data in the form of tables. And the next one is graphical representation. So the graph is another way of representing data where you can able to view in the form of diagrams. So in previous video, I told some of the graphical representations like bar chart, line chart, pictogram like this. So that and all we'll see in here now. So very first one is that nothing but what is a graph here. So graph is one type of diagram which can able to understand the data easily, and then it is a single picture which is a 1,000 words, so goes to common saying. Nothing, that is nothing but suppose I can able to represent this 1,000 words, I can able to present in the form of a single picture, then that should be very easily understandable. And the non-statistical minded people also easily understands the data and compares them. So what is the data? Suppose if I give the data in the form of a text, so some unminded, and then some people is unable to understood what the text is referring. That suppose if the same thing, if I present it in the form of a graph, so that the unstatistical minded people can also be easily understands what the diagram is, and then he can also be easily compares them. And next one is the most common graphics or bar charts and then pie charts in qualitative study. And histogram is the one of the diagram where I can able to represent the quantitative study here, right? So the graphs are very important, so which can easily understand the data very easily, and then we can there should be a single picture where it should be able to represent the 1,000 words at a time, and then it should be a non-statistical minded people can also be easily understands what's the data, and then compares them also very easily. Some of the most common graphs will be bar charts and pie charts while considering qualitative data, and then histogram is the graph what we're having for representing quantitative data. Let's see the advantages of this graphical representation. So in previous slide I discussed what are the advantages of tabulation, right? So in similar fashion, so let me explain what are the advantages of this graphical representation. So advantages should be it should be easier to read, and then we can also show the relationship between the two or more sets of observations in one look, and then universally applicable, and then it should have high communication power, and then which also simplifies the complex data and have more lasting effect on the brain. These are the advantages of the graphical representation. So graphical representation means, so advantages are easy to read, so we can able to read the data very easily. So by seeing the graph itself, we can able to compare the values of the two variables very easily, and then you can use universally applicable this graphical representations, and then high communication power, and then it should also simplifies the complex data and has a more lasting effect on brain. So see the first one, so presentation of the qualitative data. So for that I'm going to use a bar diagram. So what is a bar diagram? So bar diagram consists of equally spaced vertical or horizontal rectangular bars of equal width placed on a common horizontal baseline, is nothing but a bar chart. So it should be, so if I take x-axis and this one is y-axis, so the bar diagrams looks like this. So here will be some the values here. So based on the values that the variable is taken like this, so based on that I can able to represent the rectangular bars in between the x-axis, that is horizontal, and then vertical axis, that should be the bar chart. The categories are going to be placed on x-axis and the frequencies are going to be placed on the y-axis. So right, so if I take x-axis, so the categories are going to be placed on x-axis here, and the frequencies are going to be placed on the y-axis, right? So for presenting the qualitative data, so the very first one is the bar chart. So the bar chart is nothing but it is a diagram which should consist of several equally spaced vertical or horizontal rectangular bars of equal width, that it should be placed on the common horizontal baseline. And then the categories what are going maintained is to be placed on x-axis, and the frequencies are going to be placed on y-axis. See, this is the simple view of the bar diagram. See here, left side, so the number of students are represented on y-axis, and then health program is going to be represented on y-axis, like BPH, and then MBBS, and then optimum, and then B pharmacy, like the simple bar diagram. By taking the values, so by seeing this graph you can able to identify the number of students who took BPH. So in between the 0 to 100 it lies, right? So let it be 50. So 50 is the number of students that are studying and the BPH. So similarly I can able to see this graph MBBS. So how many number of students are studying this? So it lies 300. So 300 will be the number of students that are studying MBBS. So like this I can able to represent very easily by seeing the diagram. It's a bar diagram. So same thing, this bar diagram should also be represented in different ways, like simple bar diagram, component bar diagram, and multiple bar diagram. So component bar diagram means where the bar itself is going to be divided into subparts, and each of the part is going to be represented different values in between them. Suppose if I take this one, so blue color, so blue is going to represent something, this color is going to represent black color, and this should be the brown, and this should be the green, and then yellow, like this. So eye color, so brown, so how much a percentage that blonded eye, so brown eye, red eye, and then black eye. So eye color can able to represent it. I can able to divide the bar. It should be divided into different types and different parts. That should be based on the value I can able to represent. That should be component bar diagram. Similarly, another one is multiple bar diagram. So here multiple bar means, so I can able to compare that variable with the other variable. So black is should be the man and the red should be the woman. So I want to see, suppose in the year 2000 how many number of men people are available, and then how many number of women people are available. Similarly in year 2001, and then 2002, 2003, and then 2004, let it be. And then so by seeing the graph I can able to understand very easily. So the black is the men, so that should be like between 15 to 20, let it be 19, and then women it should be around 25. So like this I can able to represent. So in multiple bar diagram, within the, instead of representing a single bar, we can able to represent multiple bars at a time. And similarly second year, so 2001, how many number of men and women people. So like this we are having different bar diagrams we are having. So this bar diagram will be a simple bar diagram, so we can able to present the single bars only. That's why it should be single bar diagram. And then component bar diagram means where the bar is going to be divided into different sections. That should be component bar diagram. And then multiple bar diagram, where we can able to represent two bars at a time. And then second one is pie chart here. So the pie chart is nothing but it should be a circular diagram which is going to be divided into segments, and each of the segment is going to represent the frequency in the category. So the pie chart is nothing but a circular diagram. right? So which is going to be divided into some different sections. So that should be the pie chart, right? Where we can able to take each segment represent the frequency in the category, how many percentage I can able to represent it. Suppose I want to represent cartridge, and then uncorrected refractive index error, and then corneal opacity, diabetic, and then glaucoma, ARMD, how much percentage that the person is having. I want to represent it, then at the time I have to represent in the form of pie chart, and each pie chart is going to be divided into different segments that should be. So this should be considered as one segment, and this should be considered another segment, and this one is another segment. So where these values are going to represent the percentage of that value. So some of the other graphical representations will be pictograms. So in pictogram we are not going to show any kind of values. We can able to show directly the diagrams in the form of diagram. We are going to represent it. Suppose I want to know, suppose one bar, one image here, right? So one person is going to be equal to 10 people. So in France, how many number of people are present? I want to present it in the form of pictogram, so that I can able to single image can be equal to 10 people. So that 1, 2, 3, 4, 5, right? So 5. So 5 into 10, 50. So 50 people that are present in France. Well, how many number of people that are present in Italy? I want to read it. So how many? It is 6. So 6 1 equal to 10 and 60. So 60, like that. I can able to analyze this diagram by seeing the pictogram also very easily. And the next one, line diagram. So here the line diagram is another way of representing the graphical data. So here in line diagram we are going to maintain this lines. So that's why we are going to call it as a line diagram here. So here each line should be able to represent some kind of data. Normally we are going to see this one. These types of normally in a cricket sports, right? So how the number of runs that is scored by India, and how many number of runs that are scored by the India by each over, I want to represent it. At the time I have to make use of this line diagram. And then another one is nothing but cartogram. So cartogram is another kind of graphical presentation of the data. So here we can able to represent the data by using the maps, right? So what is, suppose I want to know what are the locations, or what is the what are the cities that are present in South Africa, America, like this I want to write. So at the time, as representing the data in the form of map directly, that one should be a cartograms, right? So for graphical representation of the data, what we're having is, so first one is bar graph, is the very first one here, and this bar graph we should be of three types. So simple bar graph, component bar graph, and then multiple bar graph. And then second one is the pie chart here. So this is another way of representing the graphical representation of the data, where this we can able to divide the circle into different images and different segments here. And then another type of graphical representation of data will be pictograms, where you can able to represent the data in the form of pictures. That's why it should be called as pictogram. And then another one is line diagram, so we can able to represent the same thing what we have represent bar diagram. We can also represent the form of line diagram. And another one is cartogram, where the data is going to be represented in the form of cartoons, pictures. That one should be cartogram. And then the presentation of quantitative data. So till now what I discussed should be how we're going to present the data in qualitative nature. Now how can I able to represent the data in quantitative nature? So right, so what is the only one graph what we are having is histogram. So histogram is nothing but the graphical representation of set of contiguously drawn bars, right? So in previous diagram, that is bar diagram, there should be a space in between that bar diagram, right? So that should be the bar diagram. Suppose if I'm not going to maintain any kind of gap in between the one bar to the another bar, then that should be the histogram. That should be considered as a histogram. So the most popular graph for the continuous variable. So if I want to represent the graph for the quantitative data for the continuous variable, then I have to make use of this histogram. So histogram is the one kind of picture where you can able to represent the data one after the other without any spacing in between the bars. That should be histogram. So some other kind of pictures what we're having for representing this data is that frequency polygon. So it is also one type of histogram or frequency polygon. So frequency polygon means for each and every bar there should be a line that is floating around the bars. Then at the time that should be considered as a frequency polygon. Similarly, if thing what I'm going to represent here, the values along the values I'm noting, that one should be considered as a frequency curve. And then second one is that scatter diagram. So here I can able to represent these values in the form of dots, and by separating a line one after the another, right? So that one should be considered as a scatter diagram. And next one is the time plot. So time plot is another one, so where you can able to represent the continuous data variables. Then at the time I can to make use of this time plot. So let's see this graphical distribution in detail for by taking an application in further videos. See, another type of graph representation of data will be this stem leaf display. So stem leaf display is the new way of representing data. And then box or whisker plot. So this is the other way of representing the graphical data. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.